All right, solving equations that have square roots. Now we've looked at solving equations, but we want to look at something where there is an exponent, something being squared. Now order of operation when we're solving equations is always going to be in reverse, okay, which we call SADMAP. In other words, subtract or add is going to be the first thing I look for. And in this case, it does look like we have an add, but it's in parentheses. That x plus 4 is in parentheses, so it's actually going to be the last thing I take care of. So there is no subtract or add in this equation to take care of, but there is a divide. Okay, so divide or multiply is the next thing I look for. There's a 3 times over here, 3 times x plus 4. All right, now I can get rid of that 3 times x plus 4 squared by dividing by 3 on both sides of this equation. So that'll cancel out that 3, and that leaves me with x plus 4 squared equals 27 divided by 3 is 9. Okay, so order of operation tells me to next look for exponents. So the next thing I'm going to do is see if there's an exponent. Now the way I get rid of an exponent if something is being squared, it's kind of like the opposite of add or subtract. Well, the opposite of squared is to take the square root. So I would take the square root of both sides of the equation, just like I divided by 3 on both sides of the equation. And when you do that, the square root cancels out the squared, and whatever was left underneath that radical, the x plus 4, is now no longer being squared. It's just x plus 4. And on the other side, the square root of 9, because I had to square root both sides, is 3. And I'll just solve this now like a regular equation. I've gotten rid of the parentheses. Now I've got x plus 4 equals 3. I want to get x all by itself, so I'll do that by subtracting 4, from both sides of this equation. Alright, so that's going to give me x equals 3 minus 4 is -1. So that is one of the solutions. Now you'll notice though when you're factoring and solving you get 2 answers. Well, the same thing if the equation has a square root, because now when I solved this I said the square root of 9 is 3, and that is true. The square root of 9 is 3. But when you're dealing with square roots, it's important to understand that the square root of 9 is positive 3, but the square root of 9 is 3. We say that because 3 times 3 gives me 9. Well, the same can be said for negative 3, because negative 3 times negative 3 also gives me positive 9. So a square root will have two opposite signs. It'll be the square root of 9 is positive 3, and it's also negative 3. Now, if this was a test question or a homework assignment like we have on our homework, you would see that there are 2 possible answers. We got -1 when we solved this, and -1 is an answer choice down here. X equals -1, but they have this other number over here, -7. So what they're telling us is there's 2 answers, and the way they're getting that second answer is they're using the other value for the square root of 9, because we just used 1. We just said the square root of 9 is 3. Well, if we change that and we say the square root of 9 is -3, then we have a different equation. I have x plus 4 equals, instead of the square root of 9 being 3, I put a -3. That's going to change my answer, because now when I subtract 4 from both sides, I'm going to get x equals -3 minus 4 is -7. That's where I'm going to get that other answer. Okay, so my answer, I'm going to take the square root of whatever I'm asking to find the square root of. Say it's 9. I'm going to get +3. I'm going to get one answer. Then I'm going to go back and change that to a -3, kind of like we did with the quadratic formula where we changed the sign in the equation from -b plus to -b minus, and we get 2 different answers. Same thing here, because square roots always have a positive and a negative possible outcome as their square root. So that's how we're going to get these 2 separate answers. Now the answer we get will not always be so simple, so cut and dry. We might get an answer that looks a little different than just some whole number answer, -1, -7. I might do something like this, where the first thing, I don't have any add or subtracts to get rid of. I don't have any divide or multiplies, but I do have an exponent to get rid of. So I'd say, okay, well, what's the square root of each side? That will cancel out the exponent, and that'll leave me with x plus 3 equals, well, the square root of 5. That's not a perfect square. I can't just take the square root of 5 and get an actual answer that's actually rational. I won't get, that's not a perfect square. So, and if you put that in your calculator, it would just leave it as the square root of 5. It wouldn't give you anything different. But that's a positive square root of 5. And like we said with square roots, you're going to get an x plus 3 equals whatever that square root is as a positive. You're also going to get that same exact thing as a negative, like the square root of 9 was positive 3, negative 3. This doesn't give me a perfect answer, it just stays the square root of 5, but I'm going to have a negative version of that, and I'm going to have a positive version of that, so just be aware of that. Now, the last thing I have to do when I solve for x is get rid of this x plus 3. I want x to be by itself, so I would have to subtract 3 from both sides, and that's going to be the same on either one of these. Okay, so my answer over here is going to be x equals, I've got negative 3 and there's a positive square root of 5, and on the other side this cancels out again. I've got x equals negative 3, but it's minus because that's a negative square root of 5. So these are my two solutions. Okay, so when you're looking for answers, you want to try to find the answers that match exactly what you get. Now there is a difference in how your answer is going to look here versus what it looks like on a test. You'll notice that they have a plus or minus. So we had negative 3, I believe it was, let me double check that. Yeah, negative 3 plus or minus the square root of 5. They use that symbol that kind of is like the quadratic formula. It's telling me that one of my answers is going to be negative 3 plus the square root of 5. The other answer would be negative 3 minus the square root of 5. It's just one of those things that an easier way to show it than putting it out there twice is just saying you have two answers, a positive and a negative version of that square root. Here's an example where I have more than one thing to do inside the parentheses here, but the order of operation is always going to be very similar. It's going to be in reverse. So I'm going to look for a subtract or add first. Now when I say subtract or add, I'm not talking about this 2 that's being added. That's inside of parentheses. It's going to be the last thing I deal with. But there's nothing outside that parentheses being added or subtracted. Nothing outside that parentheses is being multiplied or divided. First thing I see is an exponent. That's the first thing I'm going to deal with. And we deal with that by taking the square root of each side. So I've got the square root cancels out the squared, and that just leaves me with 3x plus 2 equals, the square root of 16 is 4. Now remember though, we're going to get two answers based on the fact that that's a positive 4, and I'm also going to have 3x plus 2 equals negative 4. So I'm going to get two different answers based on the fact that that's going to give me two different square roots. Okay. Now make sure you do the order of operation. In order again, I'm starting over here. I'm going to look for add or subtract. I'm going to get rid of that minus 2 because I have a plus 2. I'm sorry, I'm going to get rid of the plus 2 by subtracting 2, and that's going to cancel out. That's going to give me 3x equals 2. Alright, and then my last step here would be to divide, multiply or divide. I've got 3 times x. I would divide by 3 on both sides, and that's going to give me x equals 2/3. That's one of my solutions. You get the other one by using the negative 4. So I'm going to do the same thing. I'm going to subtract the 2. But this time when you subtract 2 from negative 4, you get 3x equals negative 6. Okay, and I have to get rid of the 3 by dividing. And this time it actually gives me a whole number when I divide. Negative 6 divided by 3 is going to give me x equals negative 2. So that's how I would get my two solutions. I would use the positive and negative square root. And that is how we solve equations, by taking the square root.